All right, hold on 1 second here. Let me get on the screen. Greetings. Welcome back from break. I thought I would give a quick lesson and then email you all that this is. I kind of wanted to speed through the last part of the lecture so that we might have a little bit of time to review the test coming exam. I don't think the exam is going to be that hard, I mean I think it's fair. That's so stupid to say. Of course, I don't think it's that hard. I know this stuff, so it's not new to me, and it's new to you all. So study. But I wanted to talk about the when fluids are in motion, okay, which is the last part of the chapter, and you've got like 3 homework problems, and I'd like to just look at those and get those set up for you so that everything's not a big mystery when you're because I do give you a test question over fluids in motion, so or a couple of them, and some of them are conceptual and some of them aren't. So, but anyway, so without further ado, let me get my mug off here so that we can actually get started. Okay, fluids in motion, study flow. Now I'm going to read the slide to you. I know that you're not 4, but anyway. Okay, study flow, the velocity of the fluid particles at any point is constant as time passes. So you got to study flow of fluid. Unsteady flow exists whenever the velocity of the fluid particles at point changes as time passes. So in other words, as we get closer to the shore, it goes, the water flows slower. You come out to the middle, it flows faster. Turbulent flow is an extreme kind. Okay, let's get back to, because I want you to know these turbulent flow is an extreme kind of unsteady in which the velocity of the fluid particles at a point change erratically in both magnitude and direction. In other words, they go all over the place. Fluid flow can be compressible or incompressible. We're going to look at incompressible fluids like air and water. We're not going to look at goopy things like oil and honey. Okay. Most fluid flow can be viscous or non-viscous. We're going to look at non-viscous fluids. Viscous is those goopy fluids, like I said, oil and honey is called, and so we're going to look at ideal fluids. And it's the idea is pretty darn simple. Okay. When the flow is steady, streamlines are often used to represent the trajectories of the fluid particles. So we just treat them like we just treat the water coming out of the hose as if it's a car moving with a certain velocity. Basically, is what we're saying. Making streamlines with dye and smoke. Okay, so you can see the fluids moving up over. Now this person is in a wind machine. They're probably testing this suit to see the drag on it. And when you get drag, you get all kinds of swirls and all kinds of cool stuff. But anyway, all right, now, so this 11.7. That's the conceptual part. Okay. So now let's talk about the equation of continuity, and then we'll talk about Bernoulli's equation and applications of Bernoulli's equation, and then we will be done. All right. Okay. And I wish we had more time to really talk about the baseball and the curveball, and it's really kind of cool stuff. But anyway, take physics as sport. We spend a lot of time on it without a lot of the highfalutin math. Now, a lot of this math is going to look complicated, but it's really not. So let's just get started. Okay. Let me go ahead and punch this one out, and we will start with 2. Will be on the equation of continuity. Okay. Oh, here's how I turn.